Thank you. Have a good day. I am Aliya Issainova. I'm from Kazakhstan, Astana. And I present the work of the team from Gomilov Eurasian National University. I am HPZ student. You see my report plan on the second slide.
Petroleum or crude oil is a non-renewable natural resource used mainly as a source of energy. It's also used to manufacture a diverse array of petroleum-derived products. Petroleum is mined in huge quantities. Pipelines, ships, and trains transport most of this volume, plus its refined products around the globe. The risk of spillage are always present, and oil spills cause severe ecological damage. The Republic of Kazakhstan is an oil and gas producing country located in Central Asia and particularly in Eastern Europe. The main oil reserves are in 6 largest onshore oil fields, which are located in the western part of the country. The Kashagan offshore field in the Caspian Sea is the largest oil field outside of the Middle East. Oil and gas sector is the main driver of the Kazakhstan's economy. Crude oil and gas export revenues account for half of the country's gross domestic product. Oil spills can contaminate soil, water, and air, have destructive effects on ecosystems and human health. The Caspian region has a large set of environmental problems, and the ecological status of the territory of Western Kazakhstan is characterized as a pre-crisis. New alternative, highly sensitive and low-cost tools are needed for fast and accurate identification of oil pollution using alternative technologies that can replace or supplement the remote sensing technique based on computer vision. The purpose of our study is to investigate possibilities of an electronic nose as a combination of chemical sensors array with pattern recognition techniques to distinguish petroleum, hydrocarbon, soil pollutions. Materials and methods. A crude oil from 3 Kazakhstan oil fields and 5 petroleum products from local producers were chosen as experimental samples. Petroleum products were selected spills of which actually occur both during extraction, transportation, and when they are used for mechanized land curvatation in agriculture. Used motors oils was collected in a local garage. Used motor oil is an environmental pollution containing significant concentration of toxic compounds, including heavy metals. 6 soil types were selected to cover a wide range of commonly encountered soils in Kazakhstan. An artificial olfaction system mimics the mammalian olfactory system. It can identify different complex odors comparing the incoming odor with previously learned patterns. An electronic nose uses an array of gas sensors with differing relative sensitivities. The collective response, these sensors corresponds to the odor pattern like a fingerprint, allowing the identification and classification of our samples. We applied a homemade e-nose, which included an array of 8 metal oxide semiconductor sensors. Gas sensors, temperature and humidity sensor were grouped on a separate board and connected via an analog switch to an analog to digital converter on the Arduino module. The sensor array and Arduino module were installed in a single metal housing to enable constant airflow supported by a ventilation fan. The e-nose was powered by means of an USB interface connected to a PK, also used for data acquisition. Data sets were collected in sequential series of experiments measuring sensory response to volatile organic compounds from samples of uncontaminated soil samples with introduced pollutions. To analyze and classify the sensor response, we applied principal component analysis and machine learning algorithms. Results: a less dense grade of oil contains more volatile, higher carbons, and the level of sensory response falls off faster in this case. Sulfur content in oil, AB, influences the form of sensory reactions. Petroleum products are produced from different fractions of oil with different amounts of volatile hydrocarbons. The more volatile hydrocarbons, gasoline and kerosene, the higher the amplitude of sensory response. Gas sensors respond differently to experimental samples of uncontaminated and contaminated soils, which makes it possible to differentiate both soils and pollutions. The approach allows one to discard less significant features in sensor response. The point represents the average sensor date for all experimental data for that sample. Data analysis results.
Это 24-й. Just,
Conclusion: we investigated artificially polluted soils to detect soils contamination and distinguish between some types soils, oil and petroleum products, pollutions using alternative sensor technologies that can replace or supplement computer vision and remote sensing techniques. Experimental results have shown that e-nose system is able to identify not only the presence, absence of the crude oil and PDPs in soil samples, but it can to differ the oil's brand and type of the petroleum product. In future studies, we will to determine the source and type of oil pollution on soil samples taken in oil production areas and other contaminated areas.
Sure.
Yeah. Thank you for your attention. If you have questions, you can write to this email of my supervisor.
So, question.
Переведи.
What kind of wireless technology